now continue performing different forms of aggregations on streaming data. Back to our aggregation.py source code, let's once again focus on the aggregated data frame which we create. This time, beyond the group by operation, where we still group by brand, let's replace everything else, and here is the new aggregation. We make use of the ag function in order to define, by means of a dictionary, exactly what aggregation needs to occur. The key in the dictionary points to the column which needs to be aggregated, and then the value corresponds to the operation which needs to be applied. Here we compute the max of the selling price for each brand, so we will know the cost of the most expensive phone offered by each of the brands in our dataset. This will generate a new column called max selling price with selling price in parentheses. In the next step, we rename this column to highest price, once again using with column renamed. Finally, we include an order by operation. Once again, we order by brand, but in ascending order, by setting ascending to true. Once again, this is a small change, but it will help us understand exactly how aggregations are carried out. To test things out, once again we head to the shell and rerun aggregation.py. Sure enough, this will take a while to warm up, and to start off, we should expect that 3 batches of output will be generated, one for each of the CSV files in the mobile data folder. Batch 0 has now been processed, with Google Pixel appearing at the top and Oppo at the bottom. Furthermore, we can take a look at the highest priced phone offered by each of these brands. Google Pixel has a phone which is available at 92,000 rupees based on our dataset, and this is the most expensive of the phones so far. Let's see how things change when one more batch of data is processed. In this case, Asus appears at the top, confirming that this sort is in fact based on the ascending order of brand. And when we wait for the last batch of data, which is currently present to be processed, it looks like the most expensive phone in our data so far is one offered by Google Pixel. Alright then, let's see whether our app can continue streaming data by dragging and dropping this fourth CSV file into the source folder. Once that has been dropped, we can already see our app working to process it, and soon enough, a fourth batch of data has been generated, and this includes an Apple phone, which comfortably is the most expensive phone on offer at a shade under 150,000 rupees, which roughly translates to about 2000 US dollars. We are ready now to move on to the next transformation and aggregation of our data. So let's terminate this app and of course head back over to the source code.